Speech synthesis is a key technology for making human-computer interactions feel more natural and intuitive, by turning written text into audio that sounds like real human speech. However, creating datasets for this technology has been challenging due to high costs from manual annotation and limitations in character diversity, contextual scenarios, and emotional expressiveness. In this paper, researchers propose a new framework called DialogueAgents, which is a hybrid agent-based system designed to generate multi-party dialogues more effectively. The framework integrates three specialized agents: a scriptwriter, a speech synthesizer, and a dialogue critic. These agents work together collaboratively to produce high-quality dialogue scripts and their corresponding audio. It starts with a diverse pool of characters, each with distinct traits, to ensure variety in the dialogues. The script writer agent first selects participants from this pool and generates an initial dialogue script. This script outlines the conversation, including multiple parties and turns, to simulate real-life interactions. Once the script is ready, the speech synthesizer agent converts the text into spoken audio. This step focuses on producing natural-sounding speech that includes elements like intonation, rhythm, and emotional nuances. However, to improve quality, the dialogue critic agent steps in. This agent reviews the synthesized speech from various perspectives, such as coherence, emotional accuracy, and paralinguistic features like tone and emphasis. It provides detailed feedback on any shortcomings, such as unnatural phrasing or mismatched emotions. Based on this feedback, the script writer agent refines the original script by adding emotional markers and other adjustments. For example, it might incorporate instructions for excitement, sarcasm, or hesitation to make the dialogue more expressive. This process is iterative, meaning the agents go through multiple rounds of generation, synthesis, review, and refinement until the dialogue meets high standards. This collaborative approach helps boost the emotional expressiveness and overall realism of the synthesized dialogues, addressing the weaknesses in existing datasets. Using this DialogueAgents framework, the researchers created a new dataset called MultiTalk. MultiTalk is a bilingual dataset, supporting both Chinese and English, and it features multi-party and multi-turn conversations on a wide range of topics. This makes it more comprehensive than previous datasets, which often lacked depth in participant diversity or conversation length. For instance, datasets like VCTK and WS4TTS focus on single utterances without dialogue context and rely on manual transcription, which is time-consuming and expensive. In contrast, Fisher and Daily Talk include dialogues but still fall short in handling multiple parties or turns effectively. Another dataset, KE-Omni, attempts automated synthesis but uses a sequential method that can lead to errors accumulating over steps. MultiTalk stands out because it's generated through this iterative agent-based process, ensuring better quality and efficiency. It includes more than 2 participants per dialogue, multiple exchanges or turns, and a focus on natural turn-taking and contextual emotional expression. The dataset covers everyday scenarios, making it suitable for training advanced speech synthesis models. To evaluate the framework and dataset, the researchers conducted extensive experiments. They compared the generated dialogues and speech from DialogueAgents against baselines from other methods. The results showed that DialogueAgents produces dialogues with higher coherence, better emotional accuracy, and more natural paralinguistic features. Metrics like speech quality scores, emotional expressiveness ratings, and user preference tests demonstrated significant improvements. For example, in blind evaluations, listeners rated the MultiTalk dialogues as more engaging and human-like compared to those from sequential agent approaches. The framework's ability to automate and refine the process reduces the need for manual intervention, making it scalable for future applications. By releasing the MultiTalk dataset and the associated code on GitHub, the researchers aim to support ongoing research in speech synthesis, particularly for developing models that handle complex, customized data generation. This contribution could lead to advancements in areas like virtual assistants, interactive storytelling, and multilingual communication systems, where realistic multi-party dialogues are essential.